Thank you so much for the introduction. Good morning, everyone. My name is Dánae, and I have already obtained my PhD. So this presentation is the compilation of all the data analysis in my thesis. And in this presentation, I go to show you the evaluation of the diet of South American mammals based on isotopic composition during 25 million years. So stable isotopes have extraordinary potential for climate and environmental research because they are very diverse. We can analyze them in fossils, sediments, or speleothems, for example. Also, they record a wide range of variables such as temperature, precipitation, vegetations, and they provide temporal and geographical information at different spatial and temporal scales. So in stable isotope geochemistry, we measure the radio of two isotopes, the heavy one and the light one, in a given element. So we compare the abundance of the heavy isotope versus the light isotope, and we express them in the delta notation, which is expressed by the following formula. I don't see if you see my arrow. Okay. So we compare our sample with an international standard that in the case of carbon is the Vienna PD belemnite. But why are stable isotopes important in paleobiology? Well, stable isotopes integrate ecological processes and also record the response of biological system to environmental and climatic change because animals are what they eat. Well, they are what they eat plus something, and within this something is the concept of isotopic fractionation that refers to the change in the isotopic radio between the heavy and the light one, because the stable isotopes of an element have the same chemical properties, but they have slightly different behavior in certain physical, chemical, biological processes. For example, the enrichment that occurs between the diet and the value recorded in the tooth enamel is an example of fractionation. When a herbivore consumes plants, the carbon of the diet is incorporated into the body tissues, for example, the enamel, but due to metabolic processes, we have an enrichment that in the case of ungulate is plus 40 per mil. So the value of the tooth enamels is 4 per mil higher than the value of the original plant. The aim objective of this work is to improve our knowledge on the paleoecology of the Cenozoic faunas of Argentina. So we want to evaluate the delta C13 signal of fossil mammals, to also evaluate the paleoenvironmental and paleoecological variables such as vegetation or diet. And also we want to correlate these dietary change with ecological and climatic events. To achieve these objectives, we have studied a total of 443 carbonate samples from 23 fossil localities. As you can see, the majority of the localities are in central Argentina, but we have 3 in the West Argentina and 2 in North Argentina. The colors refers to the age of the localities, and then the size of the circle indicate the number of samples in each one. Then we have analyzed 10 orders of mammal. Each color refers to its order, and then a total of 26 families. For example, the order with more samples is Notongulata, an endemic order from South America, and the family with more samples are Toxodontidae. The methodology followed was, first, we sampled the material in the paleontological collections, then we chemically treat them in the laboratory, and finally, we analyze them in the mass spectrometer. Starting with the result, this graph summarizes all the results. You can see the mean and the standard deviation of each family analysis. The color again refers to the different orders, and then the symbols are for each family. Then you can see the data organizes in temporal order since the late Oligocene to the late Pleistocene, And then in the y-axis, you have the delta C13 values. Higher values indicate more open environments and more arid conditions. I know that it is a lot of information so I think it's better to focus in the neogen first. So as you can see, in general, delta C13 values suggest a variety of diets between woodland and C3 grassland to mixed C3, C4 grasslands. It's interesting this result because in Califú and Farola de Montermoso, two localities from the early Pliocene, more or less 5 million of years ago, we record a high percentage of C4 plants in the diet of mammals, probably due to the related to the global expansion of C4 plants that occurred 7 million of years ago. So probably 5 million of years ago, C4 plants were already an available resource in South American environments. Then, when we focus in the Pleistocene, you can see that we only have one locality for the early Pleistocene, and the other ones are from the late Pleistocene. So you can see a greater variety of delta C13 values. We have some taxa with C4 diets, and also you can see that probably this more greater variety of values could be related to glacial and interglacial phases, meaning that we have times with more or less arid environments. Also, you can see that the number of families studied in the Pleistocene is smaller than during the Miocene and the Pliocene. So I would like to focus on Toxodontis, the orange squares, because we have them in the central region and in north region. So comparing the values between the two regions, we can identify if there are some difference due to geographical condition and not due to temporal condition, because we are in the late Pleistocene. In general, Toxodontis show a high dietary plasticity, but when we look at them in the both region, we can see some difference. In purple, you have the north region, and in orange or salmon, you have the central one. So if in general, Toxodontis from north region, so more arid condition than in central region. But if we focus in the MIS2 record in both localities, you can see that in north region, we have some taxa with C4 diets, meaning that in central region, all the Toxodontis show a mixed C3, C4 diet. So probably in North Argentina, we have more arid condition during the last glacial maximum. Also, it's interesting that if we compare the MIS2 in central Argentina and the MIS5, it is an interglacial in central Argentina, we have a perfect separation between both periods. But if we compare the MIS2 and the MIS3, a glacial period and an interglacial period in North Argentina, we don't have this separation, probably due to that the MIS3 is an interglacial with condition very similar to glacial periods. So probably this is the reason why we are not recording any difference. So the take-home message are that this is the first study to cover such a broad time period. Well, the first isotopic study to cover such a broad time period. Also, that delta C13 values suggest an increase in aridity and temperature during the time period analysis since the Miocene to the Pleistocene in Argentina. And this study reveals change in the diet of mammals, probably associated with environmental and climatic change, such as the global expansion of C4 plants and glacial and interglacial phases. And in the future, I would like to extend this study to the entire South America isotopic data record, because I think this is a regional case. So I think we need to know if this in the total of the continent, we also can record this change in the diet of mammals. So thank you so much for your attention.